Hello and welcome to Mathematics with Simon. I'm Simon and this is Chewy. Today we're going to look into the question of what is I to the I. So, I is the imaginary number, which is the square root of minus 1. So it's a special new number that we've constructed to be the square root of minus 1. 1 times 1 is 1, so 1 can't be the square root of minus 1. Minus 1 times minus 1 is 1, so minus 1 can't be the square root. Chewy's trying to smell some KFC. My daughter wanted KFC today and there's a little bit left over. And after this video, Chewy will get, during this video, towards the end, Chewy will get a bit of leftover KFC, although we've got to be careful about the spice and the bones. Make sure he doesn't get either. So, I is the square root of minus 1. Now, the first question is, what does it mean to raise something to the power I? How does that make sense? Because, for instance, what's 2 to the power I? 2 to the 4 is 2 times 2 times 2 times 2. That makes sense. Or 2 to the 5 is 2 times 2 times 2 times 2 times 2. But what is 2 to the I? What could that possibly mean? Okay, we're going to take a shortcut. We happen to know that e to the I pi plus 1 equals 0. This is one of the most beautiful formulas in mathematics. It's fascinating. It unites the 5 most important numbers in mathematics, e, I, pi, 1 and 0. And they're all from different fields. So pi is from geometry, e is from calculus, but they all fit together in this equation. So e to the I pi plus 1 equals 0, or if we take 1 from both sides, e to the I pi equals minus 1. Taking square roots, e to the I pi over 2 equals I. Raising both sides to the power I, e to the I pi over 2 to the I equals I to the I. Now I to the I is exactly what we're looking for, so this is good. So e to the I pi over 2 to the I is what we're looking for, but that all looks very complicated. But here's the good news, we're going to use this formula. A to the b to the power c equals a to the power bc. So for instance, 2 to the 3 to the power 4 is just 2 to the 3 times 2 to the 3 times 2 to the 3 times 2 to the 3, 4 times, which is 2 to the 12. 2 to the 3 plus 3 plus 3 plus 3. So we can see, and it's not hard to prove, that a to the b to the c is just a to the b times itself c times, which is just a to the b plus b plus b plus b c times, which is a to the bc. And I follows all of those normal rules, so e to the I pi over 2 to the I just equals e to the I times I, which is I squared, which is minus 1, times pi over 2. And e to the minus pi over 2 is 0.20788. Now this is fascinating. I mean, A, because it's a real number, which is surprising and interesting, but also just the size of it. I mean, the modulus of I is 1. So the distance from the origin in the Argand diagram is 1. Now, 1 to the 1 is 1, and minus 1 to the minus 1 is 1 over minus 1, which is just minus 1. So they've both got modulus 1. So you might expect I to the I to have modulus 1 or something, but it's actually got modulus 0.20788. I mean, fascinating. But future videos will examine some remaining questions with all of this, which is what is E? What is pi? Spoiler alert, it's the ratio of the circumference of a circle divided by the diameter. But still, we can talk more about pi and construct an infinite series to calculate it. And what does it mean to raise a number to a complex power? I mean, we found a way to do this, but still, what does that mean? And we'll talk more about that. Talk more about the Argand diagram. And how do we know that e to the I pi plus 1 equals 0? How do we know that? I hope you liked this video. If you did, then please hit like. You're very welcome to subscribe and hit the notification bell. Love to hear your ideas. I hope you enjoy your mathematics. I hope Chewy's about to enjoy this chicken. We're going to give him a little bit of unspiced simple, fresh chicken. Here he comes. I can hear his feet. It's a dog. It's chicken. You like that? I hope you all enjoyed the video. Chewy and I will see you next time.